Welcome to our senior secondary biology. In this video, we're going to take a look at enzymes part 2, and this is the final part of the topic. So we're going to finish up this topic with two subtopics. The first one is naming of enzymes, and the second one is the industrial applications of enzymes. We're going to start with naming of enzymes. So there's a system that is used to name enzymes. The system goes like this. The name of an enzyme is taken from the name of its substrate. So the substrate it works on, its name is going to be used to develop a name for an enzyme. So how is the name developed from the name of a substrate? So there are some letters that are removed from the name of a substrate, and these three letters are added to make the name of an enzyme from the name of a substrate. Let's take a look at this table to understand examples of substrate and their enzymes. So in this column we've got substrates, and in this column we've got enzymes. So here I've got an enzyme called maltose. So to name its enzyme, we've got a substrate called maltose. To develop a name for the enzyme that acts on maltose, these three letters are removed or are discarded, OSE, and we put ASE to make maltase. So that's how enzymes names are developed from substrate. The same pattern can be seen on sucrose, where we have sucrase, lactose, we have got lactase, peptide, where we have peptidase, lipids, where we've got lipase. Not all enzymes follow this system. There are some enzymes which are named in different ways, maybe not based on any system. Also, most of proteins, they don't adhere, they don't follow this system. So most proteins have IN at the end. Examples are these. Pepsin, it's an enzyme. Trypsin, rennin. So they've got INs at the end. But most enzymes follow this system. This is how enzymes are named. Industrial applications of enzymes. The first industrial applications of enzymes that we're going to look at is making of biological detergents. Enzymes are added in biological detergents. Biological detergents are special detergents that are used to deal with stains or dirty that is of biological origins. So any dirty that is of biological origins is dealt with using biological detergents. An example is blood. So if a shirt like this has got these blood stains, to wash this, you can use an ordinary detergent such as Boom, but you need to apply more effort to make sure to deal with this. The easiest way to deal with this is using a biological detergent. So how does a biological detergent deal with such stains? So enzymes in the biological detergent are going to act on this blood. At the end of the day, the shirt will appear to have been cleaned. How does this happen? So there is a process called hydrolysis, or we say the stain has been hydrolyzed. Hydrolysis is the process of breaking up something complex into something simpler using water. So when you're washing, you mix the detergent with water, and therefore hydrolysis becomes possible. So in this case, to explain how the breaking up happens, we're going to use blood as an example, which is protein. So an enzyme called protease works on the proteins, which are, in this case, blood. So once the protease works on the proteins, it's going to produce colorless amino acids. So these amino acids don't have color, and so you look at your shirt and you think like the stain has been removed, when in fact the stain has been converted to the colorless form, which is amino acids. So this is how enzymes are used in biological detergents. The next application of enzymes is in baking and brewing. Both of these processes uses an enzyme called zymase. So how does zymase help in baking and brewing? So we're going to start with baking, and for those who have baked before, you're going to find this part interesting. So when baking, we mix flour, yeast, sugar, and water. Once we do this, we are going to have a dough. A dough is something like this. So this is what the mixture will look like. So what happens after mixing? Yeast produces an enzyme called zymase. This zymase is going to act on sugar, producing alcohol and carbon dioxide. The one that is used is carbon dioxide. Carbon dioxide is a gas. So a gas that is trapped in dough will form bubbles. These bubbles will cause the dough to rise. And at the end of the day, you are going to have something or a dough that looks bigger than it was originally. Then you can continue with other stages depending on what you want to bake. If, for example, you want to bake scones, of course, maybe you can take the dough in the oven. I don't know if that's the process. I'm more interested on this part where enzymes are applied. The next stage, the next application of enzymes is brewing. So in brewing, we use cereals. Cereals are grains like maize, wheat, millet, and the likes. So the first stage or the first process that occurs is you get a given cereal, you put it in water. Once you put it in water, it will start to germinate. Germination is the process by which a seedling comes out of a seed. So once the process of germination starts, this is what is going to happen chemically. So starch, which is the main constituent of a given cereal, is going to be converted to maltose during the process of germination by an enzyme called amylase. This maltose is going to be further converted to glucose using an enzyme, by an enzyme called maltase. So once this is done, the next thing that is done is the cereal is dried and pounded to form powder. Once the cereal is in its powdered form, it's mixed with water and boiled. Then it's cooled and the yeast is added. So once you mix with water and you boil it, a paste is going to be formed, and you cool the paste and then you add yeast. Remember, yeast has got an enzyme called zymase. So after we add yeast, what's going to happen is we're going to have alcohol and carbon dioxide formed. And the way alcohol and carbon dioxide is formed is just the same as in baking. And that is yeast produces zymase, which acts on glucose, glucose then producing alcohol and carbon dioxide. In brewing, we're interested in the beer part, the alcohol. So this alcohol is going to be removed from everything using a process called distillation. The other application of enzymes is in making of sweeteners for food and drinks. What is a sweetener? This is an example of a sweetener, a classic example. These are in powdered form, they are sweeteners. You add it to water, you're going to get this drink. So what happens? How are enzymes used to make sweeteners? So in nature, glucose is abundant, but glucose is not sweet. So we convert glucose to what is called fructose using an enzyme called glucose isomerase. So fructose is sweeter. So this fructose is the one that is used to make sweeteners. The other application of enzymes is to improve juice yield and prevent gelling. So when you want to extract juice from, let's say, orange, for you to extract most, to have a high yield or to extract most of the juice trapped in this orange, we use enzymes. Again, when we are extracting the same juice, the juice can form a jelly like this. So to prevent the formation of a jelly, we use enzymes such as cellulase to prevent gelling. So this is another application of enzymes to improve juice yield and prevent gelling. Another application is coagulation of milk in the dairy industry. So here we use an enzyme called renin in the process called coagulation. So coagulation of milk is the process by which milk like this, which is in liquid form, is converted into a form which is a bit hard like this. So this is yogurt. So the process by which milk is converted to other products which are are a bit harder than milk is called coagulation. So, in short, the application of enzymes in dairy industry is in hardening of milk, where milk is converted to some of its products such as yogurt and cheese. Another application of enzymes is tanning of leather. So, tanning is the process by which leather is made soft and pliable. If you have this kind of leather, which is hard, for you to get a form which is a bit soft, you use enzymes to turn it into this. How do enzymes turn this into this? So we use an enzyme called trypsin. So trypsin works on the proteins that makes up this leather. Then after that, we're going to have this soft leather. So in short, trypsin works on the proteins that makes up leather. Then the trypsin works on the same proteins, and we get a soft leather. That's how tanning occurs, and that's how enzymes are applied. The same trypsin is used in another process, which is tenderizing of meat. So here I made a mistake. We're supposed to have D here so that it is tenderizing, not tenderizing as it is. So in tenderizing of meat, we use trypsin to convert a meat which is in this form to a softer form for people with a weak digestive system or babies. So this one is a bit softer than this one, and so people who cannot digest properly can feed on this instead of this. This marks the end of this topic. Make sure you like, subscribe, and share. Otherwise,